Hello, today I will talk about a fascinating paper called UDOP, which stands for Unifying Vision, Text, and Layout for Universal Document Processing. As the name suggests, this paper delves into document AI, a domain where models are trained to efficiently process documents, sometimes referred to as document understanding. The authors of this paper hail from the University of North Carolina at Chapel Hill and two entities from Microsoft Azure: Cognitive Services Research and Visual Document Intelligence. UDOP employs an encoder-decoder architecture, albeit with a unique twist. Models such as DoNet or Pix2Struct, which solely rely on the document image as input, UDOP incorporates both text and image pixels into a combined embedding. In this regard, it shares similarities with the layout LM family of models. These models typically consist of a transformer encoder and may incorporate text embeddings, layout embeddings, or a combination of all three modalities: text, layout, and image. However, UDOP sets itself apart by featuring a decoder component comprising two decoders, one for autoregressively outputting text and another for generating images. Now, let's delve into how UDOP operates. Given a document image V, the system first extracts the text and its corresponding bounding boxes using an OCR. Subsequently, the text is tokenized and converted into d-dimensional vectors. In the same time, the image is divided into patches, with each patch converted into a d-dimensional vector. The final embedding for each token is obtained by summing the token embedding with the embedding of the patch it corresponds to. While it's unclear whether the relative 2D position is incorporated at this stage or later, the authors claim to consider it in the process. The aggregated embedding is then fed into a transformer encoder, accompanied by a transformer decoder. The former examines the encoder output features at each prediction, while the latter reconstructs the image like on the masked image modeling technique employed in vision transformers. To train the model across various modalities, a range of tasks are employed, some of which are unsupervised, like text recognition in images, while others require labeled data, like information extraction. That concludes the overview of UDOP's operational framework. I have omitted a lot of details, otherwise the video will be too long. However, I encourage you to refer to the paper for a comprehensive understanding. Now, let's shift our focus to performance evaluation. The model underwent rigorous testing across different document understanding tasks, including question answering, named entity recognition, and table question answering using diverse datasets. The results demonstrate that UDOP performs very well compared to other established models like DoNet and the layout NMV3. What's truly remarkable about this paper is its model's capability to generate customized content. As far as I know, no existing model can generate a complete synthetic document. While certain diffusion models can generate images with embedded text, none can produce an entire document. UDOP's approach almost resembles a Photoshop modification, as the generated text retains the style of the original. If the claim holds true, that the model's raw output is generated from the original image and prompt input, I just want to say it's insane. We may very well be witnessing the dawn of a new era in document AI, characterized by powerful models for document image editing. This development may pose a significant challenge for fraudulent detection systems. Yeah, that's conclude my talk about this paper. I hope you enjoyed this video. If you want me to talk about other paper, you just have to put it into the comments. Until next time, I say thank you for watching the video and take care of yourself.